Good morning, class 12. I hope you all will be fine. So, our today's topic is factors affecting the rate of reactions. In our previous topic, I have explained how to find out the rate of reaction, rate of any chemical reaction. What are the different ways to represent the rate of chemical reaction, its average rate of reaction and instantaneous rate of reactions. Numerical problems related with rate we will discuss later on. So our next topic is to be what are the external condition which affects the rate of reaction. So I have put there the heading factors affecting the rate of reaction. So there are 5 factors which we have to understand one by one. So the first factor is to be concentration of reactant. Concentration means amount of reactant which we are using during any chemical reaction. So here I have written in a very simple format, rate of reaction is directly proportional to concentration of reactant. I mean to say if we will use large amount of reactant, then it favors the more amount of product formation. Okay, so that means it is directly proportional to concentration of reactant. Okay, now the second factor is to be temperature. Generally by increasing the temperature, rate of reaction increases because the number of effective collision increases. So here you have to understand what is effective collision here. Okay, actually whenever any product is formed, so number of reactant species, they all have to come closer to each other. Suppose there are numbers of reactant species, they are lying away from each other, they are not coming in contact with of each other, so they will not be able to form the product. So for the product formation, they all have to come closer to each other. When they will come closer to each other, they all have to collide together. When the collisions will be there, then there will be a chances for the formation of product. Whenever the collisions takes place, so numbers of collisions takes place, but only there will be a one collision which leads to the formation of product. Okay, so here we have to understand the collision which leads to the formation of product or which is responsible for the formation of product, that we call it effective collision. So for collision, that you must know that all the reactant species must acquire kinetic energy, and kinetic energy can be acquired by increasing temperature only. So that also directly proportional to the temperature. It means rate of reaction also directly proportional to the temperature. Next is to be catalyst. Catalyst alters the rate of reaction. Maybe they can increase or decrease. Both things they can do. So the positive catalyst, they increases the rate of reaction, or the negative catalyst, they decreases the rate of reaction. Sometimes we have to oppose the formation of products also to stop the rate of reaction. Then we need the negative type of catalyst. Okay, that we will discuss in surface chemistry also. Now our fourth factor is to be surface area. Surface area is also directly proportional to the rate of reaction. Here you all have to understand, suppose you are having a large area, large space. If large space is to be there, so large number of reactant species are to be entered on it, and they will react together, and the more chances of product formation takes place. Okay, so our fifth factor is to be radiation. Radiations means like sunlight or the surface of any metal, so they behave as a radiation. Here I have written rate of photochemical reaction. Photochemical reactions are what? Those takes place in presence of sunlight. So I have written there the example like reaction between H2 and Cl2 in the presence of sunlight or the photosynthesis are directly proportional to the intensity of sunlight. Suppose you have to show the reaction between H2 and Cl2. So most probably it depends upon sunlight. If the large amount of sunlight will be there, then the hydrogen easily reacts with the chlorine, and everybody knows that you have studied in your lower classes, photosynthesis always takes place in sunlight. So sunlight becomes a radiation for the process of photosynthesis, or sunlight that also becomes a radiation for all the photochemical reactions. Okay, I think you all have got it, the factors affecting the rate of chemical reactions. Our next topic is to be rate law. Rate law most probably I have taught in the chapter of equilibrium in class 11th. Okay, so here you have to see the mathematical expression which relates the rate of reaction in terms of molar concentration of reactant as determined experimentally is called rate law. So here you have to understand with the help of this equation. Suppose I have written A, B gives C, and D. Small a and small b are the number of reactant species. So as you have to mention the rate of forward reaction, it becomes directly proportional to molar concentration of A raised to the power A and molar concentration of B raised to the power B. F is to be written for forward reaction. So in forward reaction, A and B behaves as reactant species. Okay. So now you see here, if we remove the sign of proportionality, then we have to give a constant K. So I have written there Kf. So it becomes Rf is equals to Kf, A raised to the power A and B raised to the power B. In terms for backward reaction, it means if the reaction is moving in backward direction, then what were the product earlier, now they will behave as a reactant. Okay. So rate of reaction always depends upon the molar concentration of reactant. So now C and D, they become a reactant. So it becomes C raised to the power C and D raised to the power D. For backward reaction, we have to write a constant for Kb. So it becomes Kc raised to the power C and D raised to the power D. So here I have written Rf and Rb are the rate of forward reaction and rate of backward reaction. So let us consider with a simple example. Okay. Suppose A is the reactant and P is the product. So what will be the rate of this reaction? So rate law is the mathematical expression to represent the rate of the reaction. I am telling once again, rate law is the mathematical expression to represent the rate of the chemical reaction. So rate is directly proportional to molar concentration of reactant. What is reactant here? A, and this sign represents the molar concentration, and R is directly proportional to molar concentration of reactant A. That's why I have written, and this whole statement that becomes the rate law. Okay. So if we remove the sign of proportionality, then we have to give a constant. R is equals to K into molar concentration of A, where K is a rate constant. Okay. I hope you all have got it, what is the rate constant and the rate law. Let's come on the another topic, order of the reaction. These are the sum of all the reactant species in the rate law expression is called order of reaction. Means whatever the powers of reactant species we have taken, whenever from the rate law their sum is to be taken, it represents the order of the reaction. So you see here, rate is equal to K, A raised to the power X and B raised to the power Y. Suppose X and Y I have taken here, A and B can be taken here also. Okay, depend upon the nature of the reaction. Let us consider X plus Y. This represents the order of the reaction. But we must know that that is to be counted only from the rate of the reaction. Okay, that you must know that. If the value of X will be 1, Y will be 2, 3, 4, whatever can be there. So the sum of these two numbers represents the order of reaction. So here we are getting 2 plus 1, 3. So it becomes a third order of the reaction. Here I have written the important note for you. Order of reaction may be 0, fractional or negative. So I will discuss in detail later on when the order of reaction will be 0. Okay. So now come on the next topic. Units of rate constant in the different orders of reaction. Here recently we have got it, what is the rate constant. Once again we are considering a very simple equation. A is a reactant, P is the product. Okay. So for zero order reaction, what will be the rate law? What I have taught, rate is directly proportional to molar concentration of reactant. But here as we are taking for zero order, so its power will be 0. Is it clear? To removing the sign of proportionality, we have to give a constant K. So R is equals to K, A raised to the power 0. In terms of A raised to the power 0, it becomes a 1 here. Okay. So R is equal to K. So here we have to put the unit of rate. Rate, we know that change in concentration per unit time. So change in concentration is to be denoted by mole per liter and divided by second. The unit of rate is to be mole per liter second inverse. So it becomes the unit of rate constant for zero order. Here So K is equals to mole per liter second inverse. Let's pick here the one more example for first order reaction. R is directly proportional to A raised to the power 1. Earlier we have taken A raised to the power 0 because we were considering zero order reaction. For first order reaction, it is to be taken as A raised to the power 1. Okay, removing the sign of proportionality, we have to give a constant. R is equals to K, A raised to the power 1. But here we have to take A as a molar concentration also. So the unit of molar concentration is to be mole per liter because it is actually to be a molarity. And here we have to write the unit of mole per liter, unit of rate mole per liter per second. So mole per liter to mole per liter will be cancelled and we will get there the unit of rate constant for first order K is equals to second inverse. Okay, so I think you all have got it how to find out the units of rate constant for different orders of reaction. So your homework is to be, you have to find out units of rate constant for second order, third order and nth order. Simply what you have to do in that place, you have to change the number in second order 2, in third order 3, fourth order 4 and nth order you have to put there n and you have to find out the unit of rate constant and share me on my contact number. I hope you all will do the homework. Okay, that's all for today.